Okay, this video is for the calculus student that just started calculus, and maybe you're already taking derivatives, but you just don't really understand what a derivative is, or what it does, or what it means. So very briefly, I'm going to try to explain that. So I'm not going to really go over how to take derivatives. I'm going to assume you know that already. But just as a very brief reminder, we call a derivative f prime. So if it's a parent function, if f of x, the derivative is going to be f prime of x equals, you bring the 2 down, -2, 2 minus 1 is 1, anything to the 1 is itself. The derivative of a constant is 0, so the derivative of f of x is f prime of x, which is -2 times x. And I'm going to make that look just a little neater because it looked like a 3. Okay, the derivative here is -2 times x. But what does it do? What is a derivative? Okay, the derivative, we're going to call this our child function. This is our parent function. Now, child function isn't like an official math term. You're never really going to hear a teacher or a professor call this the child function, but it makes sense for the parable that I'm gonna draw here. So we're gonna ask our child function some questions about its parent. That's the derivative's whole job, is to tell us about the parent. Okay? So what we've done effectively is created an entirely new graph, an entirely new function to tell us about the old one. That's a derivative's main thing. So now I'll put that into practice because maybe that sounds a little vague. So, hey derivative, how steep is your parent at x equals -2 at this point right here? How steep is that line at that point right there? Well, let's see here. That's x equals -2. I'm speaking as the child function here. That's at x equals -2. So let me plug that into myself. So we have f prime of, instead of x, we have -2, which is equal to -2 times x, which is -2. -2 times -2 is +4. So we have a slope, a steepness of +4 at this exact point right here. So let's see here. I'm going to go ahead and plot this real quick. Okay, I went ahead and plotted f prime of x is equal to -2x. So this line right here is -2x. So at x equals -2, 1, 2, we're going to have a slope of, that's supposed to be +4. I didn't really draw this to scale, but just imagine that's right. Okay, so it's really upscale. That's fine. So at -2, our slope, our line reads, really it reads +3, but it's supposed to read +4. So we ask the derivative, hey derivative, how steep is your parent at x equals -2? And then we put that into the derivative right here, and it shot out +4, right? Which means that at here, so we're gonna, this line right here has a rise over run, a slope of 4. Okay, and we can do that for any point on this slope right here. This parabola right here. So if we asked the child function, our derivative, hey derivative, we want to know how steep your parent is at x equals 0, which is right here. How steep it is right there. Well, that doesn't look like a very steep line at all. That's pretty straight. We could walk across that, no problem. It's not steep at all. Well, let's go ahead and ask the derivative. If we ask the derivative, hey, at x equals 0, so we shoot so we shoot 0 as x here. -2 times 0 is 0. We understand that the steepness here is 0. And even if we looked on this graph right here, at x equals, that's at x equals +6, x equals 1, x equals 0, we see that our graph is outputting 0 right here, which means that we have a steepness of 0. And you can input any number into here. Hopefully I'm explaining this well. You could input any number here. You could say, hey derivative, at x equals 3, how steep is your parent? And then you put in 3 here, it gives you out a number, and you know how steep that line is at x equals 3, which is like right here or so. Alright, does that make sense? Hopefully that makes sense. If it didn't, you probably understand right now that I'm a very small channel. So if you leave a comment saying at 3 minutes and 2 seconds, I didn't understand blank. If you leave a comment like that, there is a 100% chance I'm going to see that comment. And I need to make videos, so there's a 100% chance. If you leave a comment, I will answer that question. So, please, if I didn't explain any of this well at all, if you want a video on how I took the derivative, if you want any kind of question answered, you can leave a comment, or I have my email in the description. You can personally email me, and I will make a full video here to explain to you how to do this stuff. So, please do. Thank you so much for watching. I'll see you later.